So this problem says if f of x is equal to the square root of x squared minus 2 over x squared plus 2, then f prime of 2 is equal to what? And we have four options. Well, I would notice to take the derivative of this function, we are going to have an outside function and an inside function because we have the square root of this whole inside piece. But then we also have a quotient rule we're going to have to apply on the inside as well. So let's take this step by step. If we first rewrite our function using our square root as a fractional exponent, that can help us with our setup of our problem. So we can write it as f of x is equal to x squared minus 2 over x squared plus 2 all to the power of 1/2. So now to take the derivative, we're going to find f prime of x. The outside function is the power of 1/2. So using the power rule, we'll pull that down to the front, leave the inside function the same. Subtract 1 from our exponent to make that negative 1/2. But now we need to multiply by the derivative of the inside function. So for now, I'm just going to write the inside function and then prime. So we still have to take the derivative of this. So how do we take the derivative of this? This is a quotient rule. So I'm going to write my quotient rule is if we have the derivative of a quotient, that is the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So let me rewrite. My f prime of x is equal to 1/2 times x squared minus 2 all over x squared plus 2. Now I want to take the derivative of my inside function here. So I need the derivative of the top. The derivative of x squared is 2x. And then minus 2 is going to go to 0. I'm going to multiply that by the bottom function, which is x squared plus 2. Now I'm going to subtract out the derivative of the bottom, which the derivative of x squared is 2x. The plus 2 goes to 0. And then I'm going to multiply that by the top, which is x squared minus 2. Divide all of that by the bottom squared is x squared plus 2 squared. Okay, so in this problem, I used the quotient rule. I also used the chain rule because this was a chain rule with an outside function and an inside function. Okay, from here we can simplify, but because we're looking for f prime of 2, I think that it's helpful to just go ahead and substitute 2 in so we can simplify easier. So that'll be 1/2 times 2 squared minus 2, if it'll write correctly, over 2 squared plus 2 times 2 times 2 was 4 times 2 squared plus 2 minus 2 times 2 is 4 times 2 squared minus 2 all over 2 squared plus 2 squared. All right, so let's do some simplifying. Oh, I think I dropped my to the power of negative 1/2. Let me bring that down. The power of negative 1/2 there. Okay. So simplifying some, bring down the 1/2. 2 squared is 4. 4 minus 2 is 2. Over 2 squared is 4. Plus 2 is 6 to the power of negative 1/2. Times 4 times, that would be 4 times 6 would be 24. Minus 4 times, this is 2, so that would be 8. Over 4 plus 2 is 6, squared is 36. All right, now I can simplify my 2 over 6 will go to 1 over 3. So I'll make this 1/2 times 1 over 3 to the power of negative 1/2 times 24 minus 8 is 16 over 36. Now, when I have my negative, I can flip the fraction inside. So that'll make that just a 3. So I'm going to simplify this to 1/2 times, and the power of 1/2 means it's the square root. So that's the times the square root of 3. And then times 16 over 36. Those have a common factor of 2. So we can divide out a 2 to make that 8 over 36 divided by 2 is 18. And then we can simplify that again, dividing by 2 on top and bottom. And I can write this as root 3 over 2. So root 3 over 2 times 4 over 9. And then we can cancel out a 2 from top and bottom to make that 2 root 3 over 9, which would be the final answer. Okay, well, I hope this step-by-step solution was helpful. If it was, please like the video and subscribe to my channel to see more similar step-by-step problems. Also, if you have a particular problem that you would like to see worked out in a step-by-step solution such as this, feel free to leave that down in the comments, or I also have my email address listed in the description if it's easier to send me a photo or something such as that. Well, thanks for watching and happy studies.